Thanks for downloading a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online. Now stay tuned for your 3CR podcast.
Welcome to another episode of Lost in Science. It is science on your radio, as it is every week. My name is Chris, and this week, well, I've been thinking a lot lately about how things rotate, and I'm interested at the moment in centrifugal force. So I'm going to be talking about centrifugal force and centripetal force, and I'm going to try and convince you that despite what you may have heard, centrifugal force, I think it is a real thing. So we'll be talking about what that is and why it may or may not be real in a few minutes. Stu, what have you got for us?
Well, I'm going to be talking about drugs. I'm going to be talking about genetically modified organisms producing drugs for human consumption and use.
Like medicinal drugs or
medicinal
recreational
therapeutic
drugs?
drugs, yes.
Okay.
And why do we do that? And what does it mean?
Excellent. And we are joined in the studio today by a new member of the Lost in Science team, or a special guest member, a new arrival here. Manisha, welcome to Lost in Science.
Thank you.
Can you tell us a bit about yourself?
My name is Manisha. I am a PhD student at the University of Melbourne. I'm studying the impacts of urbanization on wildlife, specifically looking at the impacts of roads on bats.
And you are going to tell us about bats, I believe.
Yes, I am. I'm going to talk about white nose syndrome, which is actually a wildlife disease that is taking over the caves of North America, and how that impacts the bats and some cool new breakthroughs that they've come up with lately.
Excellent. We like a cool new breakthrough, especially when it is saving the bats.
Yes, it is.
All right. Well, more on that in a few minutes. On with the show. Okay, yes, you are listening to Lost in Science. My name is Chris, and today I am asking, is centrifugal force real? Now, see, one of the things that people like about science, one of the things that I think science is good for, is it makes you feel smart. It makes you feel that you know something that other people don't. And centrifugal force is, I think, a good example of that. A lot of people, when they study, say, physics at high school, they learn that centrifugal force is not real, and they feel pretty clever that they know something is not what it appears to be.
And then they go into the biology lab and get to use the centrifuge, and it really confuses them.
Well, that's right. So this is why I'm going to try and go counter that. I'm going to try and convince you that the centrifugal force is a real thing. First of all, I should explain what it is. So the centrifugal force is the force you feel when you are rotating, essentially, and it's the force that makes things fly outwards. So a good example of it is the gravitron, the ride at the show. I don't know if you're familiar with that one.
Yes. You stand up against the wall. Yeah,
it's a big round room. It rotates very, very fast. You're against the wall, and you get pressed up against the wall by the centrifugal force pushing you out, or so it seems. What actually is happening is the explanation normally given is that the centrifugal force is not a real force. The real force is something called centripetal force, which is the force that makes you go around in a circle, that keeps you pushing in towards the center and not pushing you out. So in the case of the gravitron, the centripetal force is the thing that is the walls pushing against you, and that's what makes you move around in a circle. If they weren't doing that, then you would just go flying off outside the gravitron, and it would probably hurt even more. Another example would be if you swing a weight around on a string. I'm miming that at the moment.
Like the hammer throw in the Olympics.
Something like that, yeah. So the string there is pulling on the weight, obviously. The string is providing the centripetal force that keeps the weight moving in a circle. Now, this is a good example, I guess, of showing how centrifugal force actually operates, because if you let go of the string, or if the string breaks, the weight doesn't fly out away from your hand. It actually goes flying off in a tangent to the way it was moving. So centrifugal force is this is why they say it's not a real force. It's just a tendency of things to move in a straight line, and the fact that you are forcing it to go around a circle makes it feel like there is something pulling it out. And this is what the opinion that, say, someone like Isaac Newton had. He liked to use examples like this. He had some other ones with a bucket, that he would try and use to show that you could distinguish between a system that is rotating and has these kind of weird effects like centrifugal force and a non-rotating system. And so he was kind of big on the whole idea there was an absolute motion. There was, kind of thing is either rotating or it's not rotating, and there's a ways you can tell. However, that's idea of absolute motion and absolute sort of perfect universe is something that we got over a bit in the 20th century. I don't know if you remember a gentleman called Albert Einstein.
Oh, yeah, I've heard of him.
Vaguely.
Yeah. And his whole principles of relativity. And essentially, you look at how things behave in the reference frame, as it's called, that you're in. So in the case when you're on the gravitron, this big rotating room, it actually does behave like there is a force pulling you out. In the context of that room, if you didn't know you're rotating, you'd feel this force. It's the same thing. This is that causes you that, like if you tip over, if you go sliding around a corner on your bicycle, there is an actual force that you feel that is pulling you over. It kind of, in that context, it makes sense to talk about this force. Also, if you think about it, you're not in an absolute rest frame at the moment. You are on a rotating planet. So you are actually experiencing these forces now as we speak. So when we talk about like an idealized situation, we've got to remember that we're always on a planet where there is this rotation going on. You don't notice the centrifugal force, of course, on Earth because there is gravity pulling you towards the center. And gravity, so the centrifugal force from the Earth's rotation, even though we're rotating quite fast, it's about, I think, 1,600 kilometers per hour is how fast we're moving, if you actually work it out. The centrifugal force or the centripetal force that's being pulled on you is only about 0.3% of the gravitational force that you're experiencing. So it's still there, but it's pretty minor.
But there's stronger forces acting on us.
That's right. But this is where I want to come to my other point, why I mentioned Professor Albert Einstein. You probably hear me bang on a fair bit about him and his theory of general relativity this year, because it is the 100th anniversary this year, this December, I believe, of the publication of his paper on general relativity. So Albert Einstein really, in that work, he essentially pointed out that there wasn't a difference between these, what we call an accelerating frame, like a rotating system, and anything under gravity. That, for instance, you have an elevator accelerating upwards. You couldn't tell the difference between that and a force of gravity acting on you. For him, gravity was kind of the same effect as things moving and things accelerating. And it's all due to the curvature of space and time, I guess, is what the conclusion that he came to. But the point really is that in his theory, gravity isn't a real force. Gravity is just the way things naturally move according to the curve of space and time. And so, yeah, it's in the case of being standing on the Earth, if the ground wasn't there, you would just kind of keep moving in your natural direction, which would be downwards in this case. It's the ground that is pushing you up. The gravity isn't a real force. The real force is the ground that's pushing you up. So it's like your centripetal and your centrifugal force. So my contention is that if you want to believe that gravity is real, then centrifugal force is just as real as gravity. And I think we can all agree that gravity is pretty real, generally.
It's heavy stuff.
It is heavy stuff. I do want to hear, though, if anyone wants to disagree with me, they can contact us on Facebook or on Twitter, or drop us an email at lostinsci@gmail.com if they want to dispute my conclusions. I'm happy to take up the argument with whoever may want to call in. There are other fictitious forces, though. In a rotating system, you also get something called the Coriolis effect. I won't explain what that is because it really needs diagrams to explain that, but it's the reason that cyclones will rotate clockwise in the southern hemisphere and anti-clockwise in the northern hemisphere. There is a video you can watch at the moment. YouTube science video channels Veritasium and Smarter Every Day have done a synchronized experiment where one is doing their video in the northern hemisphere, one in the southern hemisphere, to test out the Coriolis effect and demonstrate how it gives you different results in the northern and southern hemispheres. I recommend you watch that and you get a view of another one of these kind of imaginary forces that basically is a real force because it does real things in the world. You can see that at www.smartereveryday.com/toilet swirl. That's toilet swirl, but I'll put the link up on Facebook and on our webpage. So that's it. As Stu said, gravity is very heavy stuff, but don't get all spun out about it.
across Australia on the Community Radio Network, you're listening to Lost in Science. Now, genetic modification is a controversial topic, and we have spoken about it before on the show various times. And, you know, there's protests commonly organised against biotech companies who produce food crops that have been modified by methods other than traditional breeding. And this technology is relatively new compared to traditional crossbreeding, which we've been doing for centuries, and selection of superior plant strains. But it does offer a very precise method for bringing specific traits to an organism. Now, before any agricultural crops were produced commercially by gene technology, medical scientists were interested in the potential for producing pharmaceuticals in this way, by modifying organisms to make the particular chemicals they wanted. Mm-hmm. So the vast majority of pharmaceutical treatments are based on compounds that are originally isolated from nature. So they go out in nature and go, oh, here's a chemical that does some particular thing. But they're often quite difficult to extract in useful quantities. So you need, to make litres of something, then going and extracting it out of a plant or out of an animal is, expensive and time-consuming. So the use of insulin in the treatment of type 1 diabetes, for example, was originally dependent on supplies of insulin from animal sources. They used to actually go get the animals, extract the insulin out, put it in, easy-to-use packages, and then give it to the diabetics.
So when animals have a similar kind of metabolism?
Yeah, basically they break down sugars in the blood in much the same way we do. So we're talking about mammals here. We're not talking about anything smaller. But I think the original experiments were done with pig derived insulin. But, cows and other things, you can use the insulin. So that meant that, supplies were effectively limited. You only have so much insulin per animal, and that made it quite expensive. So the use of a genetically altered E. coli bacteria meant that supplies of insulin are now readily available. Basically, all you need is the appropriate strain of genetically modified E. coli bacteria and a big tank to grow it in and some sort of nutrient solution that it feeds on, and it will produce as much insulin as we need. So it's cheap, free. Well, not free, but it's cheap enough that it's a commonly used treatment now.
E. coli, that's the poo bacterium, isn't it?
E. coli is pretty much the everywhere bacteria.
Right,
there's strains that will make you sick and there's strains that will do very little to you, but it is basically everywhere, and it'll eat just about anything. So, they basically just grabbed this freely occurring bacteria, tweaked its genetic makeup, and now it will make insulin. Not that it needs insulin for itself, so this is obviously a completely synthetic process that they've introduced. And in other cases, no natural effective treatment can be found. And researchers, for example, have tweaked existing organisms to produce the exact thing they wanted. So, for example, in the case of the hepatitis B vaccine, which is now available, they basically got a strain of baker's yeast to produce an inert version of the virus that causes hepatitis B.
Okay.
So, so there's genetic modification at work there. They actually modified the yeast to produce a modified version of a virus, which now makes people immune to that virus in the outside world. So the technology using microorganisms to produce cheap or altered versions of commonly used pharmaceuticals is pretty well established, and it's relatively problem-free. When you're finished with your vat of E. coli or baker's yeast, you turn up the heat, kills all the bacteria, and you can just dump it. It's just organic material then. Doesn't actually do anything in the environment once you release it, if you dispose of it properly, I guess. Mm-hmm. But recently, in the journal Nature Chemical Biology, researchers have made a breakthrough using yeast to synthesize a chemical called S-reticulene, and this has got a lot of attention from various experts around the world. The reason for all this attention is that this chemical is a precursor to a range of existing drugs that have previously only been available from plants, and specifically the opium poppy. So the production of illegal drugs such as heroin and medically prescribed drugs like morphine and codeine have relied on plantations of plants, opium poppies, in illicit plantations in the case of heroin, or in secure facilities. So in the case of morphine and codeine, they grow them, governments grow them, and they guard them very carefully, and the process is all very carefully regulated. But using this yeast in combination with other existing modified techniques, production of these drugs could now take place in a simple factory, not much different from a beer brewery. And the obvious extension of this is that if live cultures of the yeast were somehow to become available, it would theoretically be quite simple to set up a homebrew type setup to do exactly the same thing.
Right, okay.
So the worry is basically that people will be making homebrewed heroin using this strain of yeast that they've discovered that they've created.
You said initially that it can be hard to attain the plants in the right quantities. And especially, I know that they often, with new drugs, they look for like rainforest plants, these kind of things. Mm-hmm. But poppies aren't hard to grow. I mean, is there actually a problem with...
I guess, in the case of this particular drug that they're talking about, the problem is in the security of the drug, because obviously there's an illicit black market for opium-derived drugs, has been a problem for several hundred years in Western cultures and all over the world. And, I guess that's the problem, is that it is actually a very useful painkiller in medical situations, but the fact that people will take it and get addicted to it for reasons other than being, in pain, is the big problem. So the idea of having to have these outdoor fields of poppies which have to be guarded and all that sort of thing, which is actually a big cost, being able to grow this cheaply in a lab under very controlled conditions is probably, the other problem with growing things outdoors as part of a crop is that you're subject to crop failures and, plant diseases and all those sorts of things. So you do have a much higher level of control over what you're producing.
Yep, okay.
So obviously this would ensure that these kind of drugs are readily available to hospitals and medical professionals more cheaply than ever before, but obviously also the potential for black market product is enormous. Now, there are ways they could regulate this. Obviously, they're not, going to release this strain of yeast to anyone without checking their credentials and that sort of thing. But the idea that only a single cell could be grown up into a, productive culture is, I guess, the main problem here.
Yeah.
The concern is directed mainly at the potential of the small scale of the operations compared with, opium growing. Opium growing, you can use planes to spot opium fields. They're pretty easy to see from the air and that sort of thing. And they're easy to destroy as well, if that's the objective. But existing laws for possession and trafficking of narcotics will still apply to lab-produced heroin. It's not like it's a different drug. They don't have to change the laws to make this illegal. It's just illegal to have this stuff. So that's not actually going to be an issue, but the control of production is going to be an issue.
Is it going to be easier for them to, say, patent the organisms that make the drug, and so thereby something that's been around for a long time, like morphine, will now be able to be put under a patent? And
they can certainly patent the process for producing the yeast, but as it is a live organism, once you've done that, then we're in that grey area which is still not adequately resolved legally, where can you actually own a patent for a gene, or did you just discover this gene? And they have effectively just discovered these enzymes and discovered these genes and shifted them around so that they're doing what they want them to do. Look, I think probably what this does suggest for lawmakers, if they're worried about it, I mean, the technology is the technology, but whether it causes legal problems is another issue entirely. But if drugs like heroin become cheaper or more easily obtainable, it's probably a good argument for focusing on harm reduction type legal approaches to the issue rather than just, focusing on the prohibition. Because if anyone could have a little homebrew in their garage or in their garden shed, it's going to make it really difficult to keep it prohibited, and maybe they should just look at, trying to get people not to hurt themselves by using it.
All right, so I've got a story that's a bit similar to Stu's story, except it's relating to bats and how you can use different biological organisms to help with disease in the wildlife world. Basically, I'm talking about white nose syndrome, which maybe not a lot of you have heard about. It's a fungus that has been impacting about 6 million bats in North America. And it's this fungus that goes ahead and colonizes bat skin. So the skin around their nose and along their wings and on their ears. And it just rapidly spreads right through the caves, and it impacts about 70 to 90% of bats in a single cave. And then on the rare occasion, it can actually kill all of the bats in the cave. It's a fungus that has been, it's been noticed it was first noticed in 2006. And as of late, a lot of different wildlife disease research groups have been trying to eradicate it or at least treat it. And this story actually relates to one of the success stories that have come out earlier this year.
Just, do they know where the fungus originated from?
No. So white nose syndrome, there's been some accounts of it in Europe. There haven't been any accounts of it in Australia so far. But most of the stories are in the United States and in Canada.
Okay. So they don't know if there are bats that are immune to it or something somewhere else, and that's where it came from, or they just have no idea where it popped up.
I actually haven't come across anything like that.
Okay.
It could be possible that the bats in Europe or in Australia even have a immunity to it, and so it might have been in the caves here, and then they've just kind of developed it, but I'm not quite sure.
More research required.
Yeah, more research required. But in any case, so at Georgia State University, there was a team looking at how to slow down the fruit ripening process. And I know this seems kind of tangential and it doesn't seem to relate, but it does eventually. So they were looking at how to slow down peaches, bananas, apples, how to slow down the ripening process so that they could make it to the supermarket and not need to be tossed out. So basically really conserving that fruit. And as they're going through this, they discovered that they can expose the fruit to a bacterium from volatile organic compounds, and this is delaying the ripening process. And it's really delaying all of their maturity. But along with delaying the ripening, they also noticed that it's not getting moldy. And at the same time as all of this was going on, one of the graduate students on the project, Chris Cornelison, he was being bombarded, I guess, on his Facebook newsfeed or even within his friend circle. And the white nose syndrome was really taking off, and it was really in the news at that time, or at least in the wildlife world. And he just had this really bright idea, and it was just a complete shot in the dark. But if this bacterium that they're using is preventing the fruit from developing a mold, then maybe it could prohibit the growth and development of this fungus, the white nose syndrome fungus. So he took a complete shot in the dark, and he exposed a petri dish of white nose syndrome fungus to this bacterium and found that it rapidly prevented the fungus from growing and from really developing. So it just stopped it right in its tracks.
Okay.
So as the team found this out, they continued it and they tried to do or recreate this with bats. And they brought in, I believe they brought in 150 bats to an experimental setting, and they put them in a fake cave with the bacterium exposed, and they found that it really just took the fungus right out of the cave, and the bats were no longer infected with the fungus.
So do you know if they sprayed the bacteria around the cave, or was it on the bats, or what did they do?
From what I understand, they just had petri dishes with the bacterium there, and then they put it there in the same cave.
Wow.
So they didn't really need to spray it. It was just, I guess, airborne. Mm-hmm. And so it was, the bats didn't really do anything. The bacterium just started to fight this fungus.
Wow.
Does the bacteria affect all fungus the same way?
So that's what I was just about to get to. So this all sounds well and good, and it was great because earlier in May, I believe they released 75 bats back into the wild, and they're really hoping that these bats won't regain the white nose syndrome. And this would be a great success story, but the issue comes in how to really use this bacterium, because essentially it's an antifungal. So it would be, if we went into the cave systems and just said, okay, let's just expose the entire cave to this bacterium, that would be an issue. It would be like spraying the cave with antifungal or like a pesticide of some sort.
Yeah.
And you never know because the bacterium has no specificity. You can't say, okay, only attack this bad fungus and leave all the good fungus there, or have the fungus not evolve so it can become immune to this bacteria, or in whatever case, because in nature you're never really quite sure how things are going to proceed. So this is the big issue that the research group is now probably trying to tackle.
I imagine a cave ecosystem, there'd be all kinds of fungi living in there.
Yeah, I would.
Well, I mean, because especially the bats would be bringing in food, and obviously their feces would be on the floor, and something's got to break all that down.
And they tend to be pretty damp, so these systems there's probably lots and lots going on there. I'm no expert of cave systems, but I would assume that just kind of having a blanket solution would not be appropriate in this situation. If these bats then do not, like the bats that were released, if they don't pick up the disease again, so say they go out for the winter and they're in these caves and they're not picking it up from their neighbors and whatnot, then it could be a great story, because then it's just about bringing more bats in, treating them, and then releasing them. And that could be a great way to eradicate it. But it would probably be a better way than just exposing full
the entire
caves.
cave,
Because you would never really know how other organisms would respond, or even the white nose syndrome in an experimental setting in this fake cave. Sure, we've controlled for everything except the fungus and the bats, but you never quite know what's going to happen in real life.
Okay, that is it for another episode of Lost in Science. I'd like to thank Manisha for coming in and telling us all about the white nose syndrome and how it is. Well, they got a way to tackle it, I think. Potentially, yeah.
Hopefully.
Yes. Using bacteria to do good, as are the bacteria that Stu told us about.
Bacteria and yeast all making medicines for us.
Yep. And, how would you extract those chemicals from the bacteria?
Probably with some kind of centrifuge.
Probably with a centrifuge, yeah. It all comes around, so to speak. Lost in Science, it is recorded at the studios of 3CR in Melbourne. It airs across Australia on the Community Radio Network with the generous support of the Community Broadcasting Foundation. We'd love you to get in touch and tell us what you think. You can email us at lostinsci@gmail.com. You can find us on Facebook, where we are Lost in Science on 3CR, I believe. Or we are on Twitter, where our handle is at Lost in Science 1, because someone else presumably grabbed the vanilla Lost in Science. Or you can listen to us, of course, on the radio, when we'll be here same time next week to get
Lost in Science!
Thanks for listening to a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online.